Hello guys, welcome back to QST channel. Today we are going to be doing chemistry level L course question document for non-transition year. We are going to be doing the chapters for the periodic, which is chapter 5 to chapter 6. We are going to be solving the questions that are included in the material. Let's start. So the first question, a sample of 0.1 moles of oxygen gas and 0.4 mole of nitrogen gas are placed in an empty container of volume 20. The total pressure in the container is 0.5 atm. Find the volume of oxygen gas. Firstly, we know that gas expands to take over the entire container. The gas is the volume of its container. So no matter if there is 100 moles of oxygen and 100 moles of nitrogen, like both of their volume will always be 20, no matter what. It's always going to be 20. Okay, let's go to the next question. Okay, this one might look confusing or hard, but it's really easy. Firstly, they ask for the total number of moles in the gas container. Let's read the question, like the given. 0.1 mole of oxygen gas and 0.4 mole of nitrogen gas are placed in an empty container of 20 of the volume 20 liters. The total pressure on the container is 0.5 atm. Firstly, they want the total number of moles. It's easy. 0.4 the total moles of nitrogen with oxygen, which is we get 0.5 moles. Mole fraction of nitrogen gas and oxygen. Okay, mole fraction is like, for example, the total amount of moles, which is 0.5. Let's do it here. And the amount of volume of, for example, oxygen gas. Okay. So what we're going to do is 0.1 moles, because we want to find the mole fraction of nitrogen and oxygen. Since the total amount of moles is 0.5 and the amount of moles of oxygen gas is 0.1, what we're going to do is 0.1 over 0.5. If you plug it into the calculator, you are going to get 0.2. 4 O2. Okay, let's write it here. O2 equals 0.2. Now we want nitrogen. N2. Nitrogen is 0.4 moles, so we're going to do 0.4 over 0.5. Plug it into the calculator. You are going to get 0.8. It's simple. Now for the partial pressure. I'm not sure if you're familiar with this rule. It is mole fraction of O. For example, we want the partial pressure of O2. Okay, it is going to be equal to the mole fraction, which is 0.2 times the total pressure, which here the total pressure is 0.5. So what we're going to do is, for oxygen, we're going to do 0.2 times 0.5. Because we got here the mole fraction is 0.2 here for oxygen. And the total pressure is 0.5. So what we're going to do is 0.2 times 0.5. And the answer, if you plug it into the calculator, 0.1 atm. So the partial pressure of O2 is equal to 0.1 atm. And for nitrogen, we got here the mole fraction is 0.8. All we need to do is use the rule again. Total pressure equals mole fraction times total pressure. 0.8 times 0.5. It's going to be 1 second. If you plug it into the calculator, it's going to be 0.4. Or simply you do 0.1, because you got here the partial pressure of O2. You do 0.5, because we got the pressure here, 0.5 minus 0.1. You're gonna get 0.4. This is what they ask. This is how they solve it in the answer sheet. But you can do it both ways. N, the partial pressure of N2 equals 0.8 times 0.5, which is 0.4. On to the next. The volume of the oxygen gas and nitrogen gas. Okay. The volume of oxygen gas is 20 liters or 20 decimeter cubed, because as we said, they're both gas, and the gas, no matter how many moles or no matter how many gases are inside the container, it will always be 20 liters, or like the container, the volume of the container they're in. It will always be the volume of the container they're in. But for solids and liquids, it's not always they're not the total volume in the container. It's only for gases. So both of them are going to be 20 liters, or you can say 20 decimeter cubed. On to the next. They ask for the fraction of the volume of the container occupied by oxygen. As we said, it's going to be occupied 100% for everything. For nitrogen, oxygen, they'll both be 100% occupied, because as we said, no matter how many gases there are in a container or the amount of moles they will always occupy 100% of the volume. Alright? On to the next. Okay, number 7. Calculate the molar volume of an ideal gas at 27 Celsius and 1 atm. Use R equals 0.082. We can derive the rule PV equals nRT. And they want the molar volume of the ideal gas. And here we assume, because they said not assume, because they said an ideal gas will be 1 mole. It will always be 1 mole, since it says it's an ideal gas. And here they want the volume. So what we can do, we can derive it. And we can make V equals nRT over P. So we do 1 times, the R is 0.082 times 20 in brackets 27 plus 273. Always convert to Kelvin. Never ever, like in chemistry, never ever use Celsius or Fahrenheit. Always convert to Kelvin. Okay? Over the pressure, which is 1 atm. If they give it in mg, you just divide it by 760 and you're gonna get it in atm. If you put it in the calculator, you're gonna get the volume is 24.6. Okay? And if you see here, all of them are in 2 significant figures, 1.0 atm, 27 degrees Celsius, 0.082. You can either keep it 24.6 decimeters cubed or make it 25 decimeters cubed. Alright? On to the next. Okay, for this one, They want to calculate the density of hydrogen gas exerting a pressure of 760 mmHg in a container at 127. Okay, as we said, first thing we need to do is convert mmHg to atm. Okay, so it's going to be 1, and we want to calculate the density. We can use the rule PM equals dRT. Pressure times molar mass, okay, equals density times R times T, temperature. You can derive it from PM equals dRT. You can make it D equals PM, okay, over RT. We use this rule. So we have the pressure 760 over 760 to atm. It's going to be 1. Okay, so we do D. Firstly, the rule is PM equals dRT. Okay. Now we do D equals PM over RT. Here we said pressure is 760 over 700 because we want to convert it to ATM. From ATM is mmHg over 760. So here it's going to be 1 ATM. It's going to be equal to 1. And hydrogen gas, its smaller mass in the periodic table, it's always H2. So it's going to be 2. M is equal to 2. And we have temperature, which is 127 plus 273, because we need to convert it into Kelvin. And R is a constant. It's always 0.082. You need to memorize it. So it's going to be equal to D equals 1.0, or just put 1 times 2, because we said D equals PM over RT. Pressure is 1, molar mass is 2, over 0.082 times 400. If you put it in the calculator, you are going to get 0.061. Okay, for 9 you're gonna get 0.061. You do grams per liter, because density is always grams per liter. Per liter or per decimeter cubed, it doesn't matter. Okay, on to the next. 10. A certain mass, okay, of helium gas was placed in a cylinder fitted with a piston at 25 degrees Celsius. The volume and pressure were measured to be 3 decimeter cubed and 120 mmHg, respectively, if the piston was pushed till the volume reaches 2 decimeter cubed while maintaining a constant temperature. How will the pressure be? Okay, we can use the rule P1 V1. Wait 1 second, let me write it for here. P1 V1 over T1 N1 equals P2 V2 over T2 N2. Usually you can cancel N out, because it's usually constant. It's usually 1 measured at 1 mole. Okay, and here, if anything is constant, you cancel it. If you read the question, they said everything changes except the temperature. Okay, So you remove temperature. So what you'll use is P. Here you don't need to convert it to ATM unless in the answer they ask you to convert it to ATM now. So all you need to do is put it in the calculator. Pressure 1 is 120 times the current density is 3 equals the piston is now the second value of the volume is 2 after the piston pushes it down. 2 times pressure. If you put it into the calculator, 120 times 3 equals 2 times x. You're gonna get 180 mmHg. P equals 180 mmHg. Okay, on to the next. So for 11, a certain mass of helium gas was placed in a cylinder fitted with a piston at 25 degrees Celsius. The volume and pressure were measured to be 3 decimeters cubed and 120 mmHg respectively. If the gas is heated to 125 degrees Celsius while maintaining the volume at 3 decimeter cubed, what will the new pressure be? Firstly, we can say since temperature changed and volume did not change, we can cancel out volume since it's constant. So here we do P1, okay, V1, or sorry, P1 T1 equals P2 T2. Okay, the first pressure is 120 mmHg. 120 over 25 degrees Celsius plus 360 converted, 273. If you put it in the calculator, it's 273. It's going to equal to 298. So 1 second. Equals pressure over 125 plus 273. You're gonna get 398. If you plug it into the calculator, fraction 120 over 298 equals x over 398. It's going to give you 160.2684, but here it doesn't matter because it cannot be rounded. We can round it to 160. So the answer is 160 mm. 160 mmHg. Okay, on to the next. So here they ask for a certain mass of helium gas was placed in a cylinder fitted with a piston at 25 degrees Celsius. The volume and pressure were measured to be 3 decimeter cubed and 120 mmHg respectively. If the gas is heated to 125 while keeping the pressure constant, how much will the volume be? First thing we do, cancel out the pressure. The pressure is since it's constant, خلاص, we cancel it out. So what we do here, we use D1 over T1, sorry, V1, not my bad. V1 equals V2 over T2. So now, what we're going to do is 1 second. We're going to do 3 over 273 plus the first initial temperature is 25 equals V2 over 125 plus 273. 1 second, let me just move the text. So this is how it will look like. And if you plug it into your calculator, you get 4 decimeters, 4 decimeter cubed. Alright, on to the next. When 1 kilograms of helium gas is filled into, one second, if into an empty balloon at 227 degrees Celsius, the pressure in the balloon becomes 760 mmHg. Find the volume of the inflated balloon. Use R equals 0.082. Okay. First thing, we use PV equals nRT. PV equals nRT. Then you get volume equals nRT over P. First thing we do, convert mmHg to ATM. We get 1 ATM. And N, for N, helium gas, in the periodic table, helium gas its atomicity is 4. Okay? Firstly, we put atomicity here, 4. And we have 1 kg, converted to grams, 1000 grams. 1000 over 4 equals 250 moles. Okay? So we have 250 moles. And we have the temperature, 27 plus 273. We're going to get 300 Kelvin. Now we want pressure. Pressure, we got 1 atm. We want R. R is given. So all you need to do is 250 times 1 times 300 over 1. If you do that, you're gonna get 6,150. And if you get a number like this, just convert it into scientific notation. You're gonna get 6.15 times 10 to the power of 3 decimeter cubed. Okay? On to the next. Okay, effusion, okay, is the exiting of a gas from a small hole. Okay? A vessel contains equal moles of SO2 and HE gases. And the pressure is 760 mmHg. On average, which travels faster, the HE atoms or SO2 molecules? Okay, for A, we are going to do E squared equals 1 over 2, 3, 64 V squared. After that, you're gonna get here 2V squared. 2V squared equals 32V squared over 2 over 2. You're gonna get V squared equals 16V squared times, okay? So here you do here you do a square root. So you're gonna remove this and do this. It's going to be 4V of SO2. So helium travels 4 times faster than SO2. Okay, let's go to the next. B. If SO2 was removed from the system, what would the pressure become? Since they are equal number of moles, okay, if we remove SO2, since it's given here, equal numbers of moles. If we remove SO2 from the vessel, okay, we're just gonna have the pressure because we have 760 here. 760 over 2, since we're having the number of moles. Pressure is going to be equal to 380, if I'm not wrong. Let me check on the calculator. 760 divided by 2, yeah, 380. What happens to the kinetic energy of the molecules if the temperature is raised from 0 degrees to 273? Okay, so all we did here is basically originally we had 273, okay, because it was 0 degrees Celsius. Okay, originally it was 273, so because it was 0 Celsius. Now 273 degrees Celsius. 273 degrees Celsius to Kelvin is 546. If you do that, 546 over 273, you're gonna get 2. So the kinetic energy of the molecules, if the temperature is raised, is going to be doubled. Okay? Okay, 19 is just memorization. Effusion is gas escaping from tiny pores, and diffusion is they mix together, mixing of gases by colliding with each other, by bouncing off in all directions. Okay, here chapter, we're now in section 6.2. This is where they ask you for this is now here just memorizing. So which of the following statements about seawater is false? Seawater boils at higher temperature than pure water. That's true. Seawater freezes at a lower temperature than pure water. That's true. Boiling point rises as the liquid boils away. That's true. The melting point falls as the liquid freezes. That's true. The density is the same as that of pure water. That's wrong because it has an ACl. Okay, here is just memorization. I think you guys can do it. Okay, here is the hard questions. 6.4. Okay, so for this one, for the main rule you need to memorize is N equals CV. Okay, they ask for pour 100 centimeter cubed of the M is like the concentration salt solution into a clean volumetric 500 centimeter cubed flask. Add enough water to fill the flask up to the etched mark. What is the concentration of the salt solution in the new flask? Okay, concentration N equals CV, or we can do V equals N over C. And now they want the concentration. They want the concentration. So it's going to be C equals N over V. Upon the dilution, the number of moles does not change. Sorry, I made a mistake. So what we are going to do is the old volume, which is the initial volume, 100 times the number of concentration over the new volume, which is 500. If you do that, you're going to get 0.8 m. That is for part A. 1 second, let me move it to 0.8 m. B. Given 2 decimeter cubed of 1.5 solution, how many moles of the solute are in the solution? Here we use N equals CV. They want how many moles? Moles is C, which is the concentration, times the density. So we do 1.5 times 2. 1 sec. 1.5 times 2 going to give me 3 moles. That's it. The answer is 3 moles. Okay. 13. What mass of ammonium chloride NH4Cl are present in 0.2 decimeter cubed of a 0.5 concentration NH4Cl? What volume of a 0.250 concentration K2CrO4 solution contains 38.8 grams of K2CrO4? Okay, let's solve A first. The mass, okay, of ammonium chloride. What we can do is mass equals, because we have N equals M over M. So we can do is, or what we can do is mass. 1 second, let me write it here. Mass equals molar mass times concentration times the volume. The molar mass of what do you call it? Ammonium chloride is 53.5, the molar mass. So what we can do is the concentration is 0.5 times 0.2. Second, 0.5 times 0.2 times 53.5. That is the molar mass. Plug it into the calculator. We get 5.35 grams. Significant figures, 5.4 grams. Okay, 4B. What volume of 0.25 concentration of K2CrO4 solution contains 38.8 grams of K2CrO4? So what we want to do is we want the volume. Okay, so we can do C. We can do, sorry, we can derive the rule. N equals CV. We get here, as I wrote it up here, C equals NV. So what's gonna happen is C equals mass over molar mass times volume. So we want the volume. Oh, sorry, they want the volume. The mass is given 38. So we're gonna do 38.8 over the molar mass of K2CrO4. If you open the periodic table, you're gonna have it in the exam. You add them together, 194 times the concentration, which is the volume, sorry. So the concentration, I mixed it up, sorry. It's going to be V equals 338.8 over 194 times 0.25. Plug it into the calculator. You get 0.8 decimeter cubed. Decimeter cubed. For C, given M equals 73 grams, because there's 2 decimeter cubed of a 1 concentration, 1 M concentration, 73 grams of an acid X. What's the molecular mass? We can derive the rule C equals N over V. Then we get C equals mass all over molar mass times volume. C equals M over molar mass times volume. Put it in the calculator. 1 equals 75, 73 over 2 decimeters times X. If you put solve, you're gonna get 36.5 molar mass, 36.5 molar mass. So that's it. On to the next. Okay, for 14, explain how you would prepare a 1 liter of 1 concentration and NaCl solution. Okay, so for 14, they want the mass needed. We can do N equals CV, and or we can do, we can use N equals CV to find the amount of moles. 1 times we get 1 liter times 1 concentration is gonna be 1 mole. Okay, for the amount of mass, N equals M, the molar mass, times moles. Okay, and the molar mass of NaCl is 58.5, so we get 58.5 grams. We need to find the mass first, and now we need to add solid to the 1 because we need to prepare it. We need to add 1 decimeter cubed volumetric, add the solid to a 1 decimeter cubed volumetric flask, and add some distilled water to dissolve the solids. This is all memorization here. You can do this on your own. I just helped you with the calculation part. You need to memorize what to do in a lab, because this is lab procedure. Okay, 15. If 1 mole of a solute is dissolved in enough water to make 2 decimeter cube of solution, what is C, the molar mass concentration of this solution? Okay, here we can use we can do N equals C over V, CV. We can derive it, we get C equals N over V. 1 mole over 2 moles, we get 0.5. So A is going to be 0.5 M. B, how many moles of a salt should be dissolved in 0.5 decimeter cubed of water to make a 0.25 solution of that salt? They want moles. Mole N equals C concentration times the volume. Okay, 0.25 times 0.5, plug that into the calculator. 1 second. 0.25 times 0.5, you get 0.1125 moles. What is the volume of a 0.1 concentration solution that contains 0.2 moles of a salt? As we said, N equals C over V, so CV. We do V equals N over C. 0.2 over 1, we are going to what do you call it, the volume is going to be 2 decimeter cubed, because 0.2 over 0.1 is going to be 2. Okay, I skipped a few questions because they are all memorization, but I'm gonna do this one since it is there's a lot of calculation involved. It may look complicated, but it's easy. First thing you want to do is write down these chemical equation, like the formula, in like your copybook. Just these chemicals, write them down. Okay, first thing you want to do, they want you to find the concentration of all ions. C is equal to NV over here. I wrote here. C equals N over V. And the total volume, 0, here is 1 and 0.4. Total volume is 1.4 decimeter cubed. So we want to find Na plus SO4. It is among the table of what do you call it, polyatomic ions that you need to memorize. Okay, now SO4, Cl minus, and zinc. Zinc is 2 plus. Okay, so the total is 1.4. Concentration is moles over volume. Na 1.4, 1.4, 1.4, 1.4. Okay, first thing we can say is there is 0.1 moles of Na2SO4 and 0.1 mole of zinc chloride. So for every Na, okay, for example, for every Na, it is 0.1 moles. Here we want that the total concentration, the concentration of all ions, Na, there is 0.2 moles because there is 2 Nas. So you do 2, 0.1. For SO4, it is a polyatomic ion. There is only one, so it's going to be 0.1. Cl, there is 2 Cls, so it's going to be 2, 0.1. And for zinc, there is just one zinc, so it's going to be 0.1. If you put all of them in the calculator, the total concentration of Na will be 0.143 m, and SO4 0.0714 m, and Cl minus is 0.143 m, and zinc is going to be 0.0714 m. That's it. That's all of their concentrations, and we finished the chemistry course revision. I hope you guys enjoyed this video, and please guys study well for your exams, especially chemistry, because it is really complicated. If you didn't memorize all the rules, you're gonna have to memorize a lot of them, And I wish you guys the best of luck in your exams. And I wish you guys the best of luck for all of your exams. And please have a wonderful rest of your day or night.